Hello guys, welcome to next class of analog communication lab. Today we will learn about the amplitude modulation and demodulation. So our first experiment is amplitude modulation and demodulation, in which we will see different conditions of modulation like over modulation, under modulation, critical modulation. These things we will see. As you already know what is modulation. Okay, so this is our first experiment, amplitude modulation and demodulation, inside which you already know the formula. This is our message signal, am cos 2 pi fmt or am sin 2 pi fmt, in which 2 pi fm is also called known as omega m, which is known as angular frequency. Am is the amplitude. Ct is your carrier signal. Okay, this is called carrier signal. Sorry. Okay, which is ac dot cos 2 pi fct. This is c. Okay, so uh, in case of carrier signal, this fc will be large, very large in comparison to fm. Okay, the signal we are modulating is fm. Okay, message signal. This is our original signal, in which we are adding some carrier to transmit it, okay, in the form of am modulated signal, which is called as amplitude modulated signal. And this amplitude modulated signals formula is this one. Okay, ac under bracket 1 plus ka mt bracket close cos 2 pi fmt, or we can write it as 1 plus ka mt into ct. Ct is our carrier signal. That's it. In which this is your modulation index ka, which is also, you can say, it is the ratio of am by ac. Am is the amplitude of message signal and ac is the amplitude of carrier signal. And this ka variation means if this ratio of am by ac is greater than 1, then it is called as over modulation. When it is equal, means then ratio will come as 1 and the modulation will be critical modulation. And when it is less than 1, then it is called as under modulation. Okay, so this is the theory part. This is your manual. As you can see, what we do in modulation, it is the modulating signal generator we use, carrier generator we use, we give it to AM modulator and we get AM wave. What we do in demodulation, modulating signal, what we get it in the form of AM. Again, we will add it with the carrier generator, okay, and then AM modulator, and this AM demodulator is just another block, and we will get the modulating signal. I will show you how we get. Okay, we have a program for that. I have given this program here also. Okay, I have included this program, but I will show you in our Matlab. Okay, so this is the interface of Matlab. As when you will open your Matlab, it will look like this. Okay, this is the folder which you are going to access in left hand side top, and on bottom the script running behind will show. You don't need this one on bottom one. This is your command window. Okay, whatever you will write, it will come here. Whatever command you will give, it will come here. Okay, you can use this to type any code. And on right hand side you will get this as workspace. You can see the, whatever, when you will type any command, okay, when you will write any program, then you will give some variables to that program. Means a is equal to 5, b is equal to 10, and you are, if you are going to add it, then you will write some a plus b. Okay, so this workspace is just, it will save that a variable in the form of matrix, it will save that b variable in the form of matrix, or whatever formula or variables you are going to give in this program, that all things will be saved here in the form of matrix, as you can see. Or if it will be constant, then it will be constant like this. Okay, so this is the work of box that you can see also by clicking here. Also you can see what are the variables you are using and what's its value. Okay, so this is our command line. We can write our code here also. Okay, but we don't need it because you can't save this command window in as a file. Okay, so what we will do, we will write in the form of script. As you can see in left hand top corner, this is a blank script. Okay, you can write in the form of this script. When you will click here, it will open just an editor window like this, and here you can type whatever the program is. Okay, I have written already, my program is already written, that's why I am not going to open this blank one. I am just going to no, I have saved this. You can just open it from here also. See, when you will go to open option, you will get your previous saved file. Okay, or it is also showing here. Here you can see a mod, a mod, dmod. Okay, .m file. It will be saved in the form of extension of .m file. I will just click here, double click, and it will open. Okay, so this was my program. Okay, okay. So one by one, I will tell you how I have written this program. This is almost like C. Almost like C. It is easier than C because here there are some commands Matlab will give you. There will be some difference like C. Okay. Here you can directly use some, means plus sign for sum, directly use into sign for product, all these things. And there are some commands, okay, which will be used in the form of Matlab commands only. Okay. So these things are a little bit different, but almost if you will see the algo type, then it is almost similar to C. Okay. So here you can see I have given first close all, clear all, and CLC. This is just to close previous program, clear all the command windows and everything. For that, we always include this one. Okay. Now we don't need any header file here because it is already running in a Matlab environment. Okay, software. So this all the header. Why we give header file in C, because it takes the our background input from there. Okay, command. Why we are using those commands? Those commands variables are mentioned in your header file. But here we don't need all these things because it is running in Matlab only, Matlab environment only. Okay, so we will directly start from FM. Okay, I have given FM as 10 hertz. Okay, FM is the message signal frequency. You have to write just includes percentage here and give one command. Command is like message signal frequency. You have to mention for each and every why this term you are using, you have to mention in a command form. If you will add this percentage sign in anywhere, then it will be act as command only, act as a comment only, not command, sorry, comment only, and it will not be counted in program script. Okay, so this is percentage sign is used. If I will give percentage here, okay, okay, so see this line becomes comment. Now when I will execute this program, compile this program, then it will not go to this line because this is included with percentage and it will consider, Matlab will consider that this is a comment line, not a command line. Okay, so I will remove percentage. I will give percentage here because this is the carrier signal frequency. Okay, carrier signal frequency. Okay, here copy it, and this I have given this as a message signal amplitude. Okay, and this is your carrier signal amplitude. Okay, so this is your time span, means time span. Okay, right, sorry, I haven't given. Okay, so this is how you have to include for each and every command. You have to include the comment message signal angular frequency. Okay, so it will be very descriptive. If afterwards, after some time, after 1 month, 2 months, or 3 months back, after some time in future, if you want to, if you will forget all these commands, then you will know, when you will open your script, then you will know why you have used these things, and this is how your commands are written. Okay, so this is why we used to give comment lines for each and everything. Okay, this is the thing. So I am writing it, you can see, and you have to also include it in your lab report or in your Matlab program. Okay, got it? This is your, what is this? This is your message signal. This is your carrier signal. This is your, yeah, this is your AM signal. Okay, so till here you can understand. Okay, so till here I have already told you this is the time. For time axis we use this one. You can see this starts from 0 and it goes till 0.5, not much, from 0 to 0.5, and the steps taken is 0.001. Okay, very little steps. Okay, so this is our time axis. Time, changing time, means this is starting from 0 and it goes till 0.5, so it will change, keep on changing with the step of 0.001. Okay, so this is our time. Now you understand this omega m, message signal angular frequency, which is also 2 pi 2 into pi into fm. Okay, same thing goes with omega c, 2 into pi into fc. This is your modulation index, what I have already shown you. It is am by ac modulation index. Now comes the message signal. Okay, these are the variables we have, what we have to give in our message signal, and now in the form of cos into am, this our message signal is obtained. Same thing goes with carrier signal, AC into cos into omega ct. Omega ct you can write, or you can write 2 pi fc into t, no problem with that. So I got my message signal, I got my carrier signal. Now I need AM signal. So for AM signal, you know the formula, 1 plus Ka into mt. Now we have to give the element, because we are going to multiply this Ct with whole of this under bracket equation, means into this Ct will multiply with 1 also, and this Ct will multiply with Ka into mt also. That's why we have given dot here. Okay, it will represent the element wise multiplication, and then we have given into. Okay, that's why we use this both. So this comes our AM signal. Now what we will do, we want to see different graphs. Okay, that's why in one figure only we want to see different graphs, so that we can compare those graphs. Okay, that's for that we use one command called subplot. Okay, in subplot first we will mention row and column. Okay, it will start with row. So in subplot I need 4 rows. Okay, in a figure we need 4 rows, because I want to use this 4 row for 4 figures. Okay, then how much column? We want only one column right now, only one column. Then this figure, what I am plotting right now, it will come on figure number on first place. Okay, that's why this one comes. So what I am plotting right now is message signal, is our message signal. So under plot command, I will give x-axis and y-axis. What will happen? So on x-axis, I need t. On x-axis, I need t. Okay, so my time will vary. On y-axis, I need my message signal. Okay, which is a cos wave here. You can use cos wave, sine wave, it doesn't matter. It's on your wish. Okay, so on y-axis, we need our message signal. Right? Title I am going to give here in the form of title. You will write title. It is a command of Matlab. This plot is also a command of Matlab. This subplot is also a command of Matlab. Okay, and this S1, CT, MT, this is just the name I have given. Okay, this is on you. You can change it whatever your convenience is. Got it? So this title, under this title command, under this inverted comma, I will write modulating or message signal. Frequency I am using 10 hertz. You can see FM is 10 hertz right now. That's why I am in bracket I have mentioned 10 hertz. Okay, so subplot is, now this is for our message signal. I have used these things for our message signal display. Okay, this message signal will come on subplot 1. Now I want to display the carrier signal also, this CT. This CT will come on second place of this subplot, second place, or you can say in second row. Okay, so same command, plot T CT. Now I am plotting our carrier signal, and title I have given carrier signal. Okay, now this third I am using this third place. You can see third, subplot third. Okay, this I am using for TS1. What is my S1? S1 is the AM signal. Now I am using this to plot our AM signal, modulated signal. Okay, and then what I am doing extra here, I am adding this. This is one signal, no problem. I am plotting this second signal, which is A, which will also vary with T only, means x-axis will be T, and the y-axis will be CT plus MT. Okay, AC plus MT. This AC, sorry. This, yeah, AC plus MT, amplitude of carrier signal plus message signal, and other axis will be varying with T, and it will be the negative, means minus of AC minus MT. What it will do, it will just give you the envelope. Okay, you will see in your plot. Okay, when I will plot here, you will see the plot. And right now my AM is 1 and my AC is 2. So what is the value of modulation index? 1 by 2. 1 by 2 is 0.5. So it is less than 1, then it is called as under modulation. Okay, that's why I have written under modulation here. Okay, now this is the, so that's why I have plotted here this plot, and the title is under modulation. Now comes the demodulation of AM signal. Demodulation, in demodulation we use one filter called as Butterworth filter. You will learn about this Butterworth filter in your theory class. Just know that this Butterworth filter can be used as low pass filter or high pass filter, whatever you need. Okay, right now I am using it for low pass filter. Okay, low pass filter, and this Butterworth filter will be of different order. Means you have learned in your control system that there is one order transfer function, two order transfer function, three order transfer function. So according to that, this butter filter works. So it will be of different orders. Okay, I am using 5 order Butterworth filter. Why? Because when you will go for the higher order, then its filtration capacity will be very good. Okay, higher order filtration capacity, and this is 0.1 is the pass edge frequency, just in form of hertz. Okay, in form of hertz, you will see its worth. And I have assigned, because this Butterworth filter will give you two variables, that's why I have assigned it in the form of matrix BA. Okay, BA. And this R1 is just the multiplication of our AM modulated signal into CP. Again, I am multiplying our AM signal with our carrier signal in modulation part. Why I am multiplying it? So that its frequency will rise again. Okay. So if its frequency will rise, it will become from 500 to 2500 or 50,000 hertz. Then what will happen? It will be very easy to us to filter the lower frequency message signal from that overall signal. Okay, that's why we are using Butterworth low pass filter here of order 5 to filter our message signal from this modulated signal, overall modulated signal. From this overall modulated signal, I am filtering our message signal back at the receiver side. Okay, this is the process of demodulation. Okay, so I have represented as MR whatever the recovered signal, and again I have given one filter which variable it will take B and A, which is of Butterworth, and this R1 it will take, which is as this signal. So it will filter it out and it will give the message signal back to us, and we will name it as a demodulated signal, and we will place this signal on the fourth position of our subplot, and this is the plot command. So this is how we write our code in Matlab for amplitude modulation and demodulation. Okay, you have to write comment line. Okay, don't forget that, this is very important. So now what I will do, I will run this program. Okay, from here, from above you can see there is one run button where I will click run. Okay, and here you see the figure. Okay, this is our figure. See, this comes under subplot. There is 4 row. This is 1 row. This is second row. This is third row, and this is fourth row, lower one. So on first row, I kept my message signal. As you can see, this is our message signal. Okay, the cause signal. Now on second, we have placed our carrier signal of 500 hertz. So this carrier signal is hertz is very high. That's why it looks like this. Okay. On third row, we have placed undermodulated signal. So undermodulated signal will come like this. Okay, there is difference between here. This is VM, this is VC maximum, this is minima, and when you will subtract from maxima to minima and the ratio of with addition of maxima plus minima, then again you will get modulation index from here. Okay, so this is and you can see this border envelopes upper side and lower side. So we have given one extra plotting command for this T and AC plus MT for this above one, and T comma minus AC minus MT for this lower one. That's why I have used those command to show you this envelope. Okay, this is the envelope. So it is very nicely shown here. Now at last you will get the demodulated signal. At first we haven't get the demodulated, but after that we are getting some demodulated. It is just the message signal replica, almost replica. You can't get the exact one, but it is almost a replica of message signal. So this comes at the source side, receiver side. Okay, so this is how we write our code. If I will change the value of our filter, you can see the, if I will give it as a 2 order Butterworth filter, then what will happen? You see our modulated signal changes. This changes. Okay, everything depends on its order. Okay, everything depends on its order. Okay, so this is how we used to write the code, Matlab code. Okay, so you have to write this Matlab code, you have to observe this figure, and you have to include these things in your lab report. Okay, now I will come to second part. This is okay, so you have to write your lab report like this. You have to mention the theory, block diagram, modulation, demodulation, then you have to mention the program. Then this you have to you can script this procedure part. You don't need this procedure part. Expected waveform you have to include. What is the expected waveform? Modulation index you have to take modulation index, whatever the modulation index. Here you can change the modulation index by changing AM and AC value. Okay, if I will give this AC as 1, okay, then our modulation index will be 1 because AM by AC will become 1, and then I will run this. Then you can see the output. You can see this. This is the form of critical modulation. See, there is no difference here. It is quite good. This is not. This will be not under modulated. This will be critical modulated. Okay, so this is how you will change different value, and then you have to write down a different value. Don't use this table. Just show the figure you got it here for Matlab. Just include that figure under modulation, perfect modulation, over modulation, everything. Okay. So, and demodulation figure will be there, and at last you will write the result. Okay, in result, whatever the result you got, you have to write it down. You have to explain it down in 4 to 5 lines. Okay, so this was the AM modulation and demodulation using Matlab coding. Now the second part, second experiment we will come. The second experiment is about the Matlab Simulink. Okay, there is two way you can do everything in Matlab. Okay, there is one thing is all about coding, like what we have done right now, and the second thing is all about Simulink. In Simulink, there are different blocks. So this is your second experiment, AM modulation using Matlab Simulink. You can see here, it is using Matlab Simulink. So this is the block diagram of Simulink. What we will do here, we will use different blocks. We will drag and drop different blocks here. Okay, for generation, for demodulation, for product, for sum, everything. And we will observe the waveform in scoop. You can see that this is the scoop. This is just like the CRO. Okay, in Simulink it is called a scoop, where we will observe the output. So this is the message signal generator here. This is one constant generator. This is one carrier signal generator. Okay, this message signal plus 1 is going here. So sum is there. So you know the formula, 1 plus Ka into MT is here. This output comes into, and it will be producted with in the form of this product, and then you will get the output in the form of AM, and this output will be observed in scoop. Okay, and we are observing carrier signal also in scoop, and we are observing this message signal also in scoop. So there are three signals in scoop. Now again we are going to the demodulation part. What I am giving here, this is the saturation. So this is one block of saturation. What will happen in saturation? Saturation will just saturate it with, means it will give the limit. Some means my AM modulated signal, if it is coming till 5, its amplitude will go till 5, or its lower amplitude will go till -5, then it will limit your upper amplitude and lower amplitude. Whatever amount you want to give the limitation, you can mention it inside this saturation block. Now the saturated signal will come to our Butterworth filter, what we have used in coding also, Butterworth filter for filtering. Okay, so this is the filtering. Just this is written LPF. This is just the low pass filter. Okay, or you can, the block name is analog filter. Okay, so this is just the filtering. Okay, it will remove the carrier with carrier part, and it will take the message signal out. Now this is just the shift, means if there is some minus part in our message signal, then we will add some shift, means some constant we will add. This is just the constant. We will add some constant with our output of filter here, and then it will go into gain. Gain is just a multiplication, means it will multiply. If my message signal amplitude is 1 or 2, then it will multiply, okay, with 5. Here it is used the 5. Okay, so this is just the gain, or you can say the amplification. We are doing the amplification of our filter output. Okay, then this amplified part will be shown in this scoop. This attached to one scoop, and this the Butterworth part is also, Butterworth output is also attached to the scoop, and this saturated output is also attached to the scoop. So this is our output scoop. This is our AM modulated scoop. Okay, you can say, and this will show our demodulated signals. So this is the block diagram of Simulink of AM and AM modulation and demodulation. So this is your second experiment. You have to write the lab report for this also. Why I am giving this, because you will learn about Simulink also, about coding also. So it will be very beneficial for you in future, so that you can perform anything in the form of Simulink also, in the form of coding also. Okay, whatever you required. Okay, so this is the way to learn your Matlab. Okay, and Matlab is very important software. Otherwise, you won't survive your BTech without learning Matlab, at least in electronics. Okay, Matlab is very basic, and you will find everything in Matlab. There is packages for everything. There is one communication package also here. for this type of communication things, analog communication, digital communication, there is one package, toolbox is there. So everything is available in MATLAB. Okay. Then so this is your the block diagram. You have to attach this block diagram also. Okay, skip this procedure part, or you can write down the procedure. It is just 5 lines procedure. Okay. Then you comes to the parameter part. So the this message signal generator, if you are taking, then what are the parameters inside that? That screenshot has been attached. So here in signal generator, you are taking sine wave. Okay, the amplitude is 0.5, frequency is 5 hertz. Okay, or you can take 10 hertz, or amplitude you can change it to 1 or 2, whatever you want. Okay, and the unit will be in hertz. So this is our signal generator, means message signal generator. You can see on right side, this is our carrier signal generator. Here the amplitude and frequency changes. Okay, then it comes to sum. So this is the sum block. This block is the sum block. So its parameter input is this one. Okay, what we are using as a parameter input is this one. Okay, then again there is one constant we are adding. Constant is this one. Okay, so here this constant. So we are adding one as the constant here. So its parameter input what we are giving, it looks like this one. Okay, on right hand side. So they are different, and we are using product also, then we are using saturation also. The upper limit you can see, the lower limit you can see. So product, in which you are using two inputs to take the product. Okay, here the function block, the sample time. Okay, so these things you set in your parameters. Then this is the analog filter design parameter. Here I am using Butterworth filter. Filter type is low pass. Okay, so here I am using 3-order filter. Pass band age frequency is 100. It is in radian per second. Okay, when you will go for in hertz, then it will be different. Okay, so you have to convert it now. It is, I think, 1 radian per second is 0.15 hertz. Okay, like that. Okay, so this is your Butterworth filter parameter. This is your constant parameter again. This is your gain parameter. Gain I am using 5 here. Okay, so I have given 5. So I have attached all the screenshots of these parameters in the lab manual. Okay, so I will go for this thing in Matlab. So how you will go for Simulink? So for Simulink, go for home. Here, click on home button, and in home button, here on above you will find this Simulink. Okay, so just press it, Simulink. It will take some time. Okay, and now Simulink is open. Okay, so for here, go for blank model. Click on blank model first. Okay, it will take some time. It depends on your PC RAM and hardware speed, processor speed. So all these things, it depends. So see, here my blank model has been opened. I will make it big. You can see here, this is our platform for Simulink, and from here you will get the library. Click here, you will get the library. So this is the library. Okay, this is the library of everything. See here, I told you that you will get one communication toolbox also. See this modulation, equalizer, channels, communication filters are already there, common sources are already there. Okay, modulation is there, sequence operation, these things you will learn in your future semesters. So communication toolbox is already there, control toolbox is there. Okay, LTI systems, you have already learned these things. Deep learning toolbox is there, neural network toolbox. So everything toolbox is here. From here also you can learn, means all the things are already present in Simulink. Whatever you can do in coding, you can do in Simulink, Matlab Simulink. Okay, so I will not get into that. Here what we need, first we need one message signal generator. So I have gone into this source. Okay, in source you will get different source. You see, you will get sine wave also here, sine wave, signal generator also, uniform number, step generator, waveform generator, whatever type of source you need, you will get it from here. Okay, this is constant also is available also. Clock is also available, what we use in our digital circuits. Clock is very important thing. Okay, so I will go for signal generator. I will just drag it from here to our platform, so it will take some time. Okay, so see, my signal generator already came here. Okay, what I will do, I will just double click here on signal generator, so you can see this parameter window is open. Okay, so this is what you need, and you will take the screenshot of this, what I have attached in our this manual. Okay, so this is our power parameter generator. Okay, so here the frequency I will give 10 hertz, amplitude I will mention 0.5, no problem with that, and sine wave is already there. Okay, So this will be in Hertz. Okay, I'm using in Hertz. I will click OK. As it is, I have included in manual. So this is our signal generator already done. I will drag it using left key from here to here. Okay. Now we need one again. We need one more signal generator for our carrier wave. So I will just do this from our left mouse key, and I will Control C this, and I will paste this Control V here. Just Control C, Control V here. Okay. This is same. But here I will use amplitude as 1 and frequency as 200, 500, whatever you need. Okay, and this is in Hertz. So this is for our carrier. Now I will show you one. Yeah, I will, and then you need to name this one. Okay, so just right click on it. Right click on any of your blocks. Okay, so this will open, and here you can name whatever the name it will appear you from here. Okay. No, under format go for show block name. It is on auto right now, make it on. Okay, so you can see the signal generator 1 is appeared here. Also I can do go for format and go for show block name on. So this is signal generator, this is signal generator 1. Okay, now we need one constant as it is shown in your manual. You need one constant which value is 1. So again you have to open the library and you have to drag the constant from there. So this is my library. You can drag constant from here. Okay, this is already under source library, or you can search it here also. Here, if you are not getting anything, you can search here also. Just type the name and it will come. But we don't need to open this library browser right now. I will cut it down. What I will do, just double click on this platform anywhere, just not on the blocks, anywhere on blank space, double click. See, your search option will come here only. And what block you need right now? You need constant. Just type constant, and you can see there are different constant blocks have appeared. So you need just a simple constant one. Just click first one. So you can see this first one came here. Okay, and just double click on this. You will see the parameter window, and you need one as the constant. Okay, sample time is okay, no problem with that. Okay, make it okay. So this is how you go for each and everything. Just observe the parameter out. Just observe this one. What are the blocks here? Okay, I will make it in a small window here, and I will going to connect it. Okay, so here we need this sum. Sum is here, so I need one sum. So I will double click here. I will write sum, and the sum will come. Okay, sum has come. First I will collect all the blocks. Then we need product. Double click product. Okay, product is here, no problem. Inside this sum, we all these parameters are okay, no problem. Inside this product we need two input only, because we are going to product 2 only. So an element wise product will be there. Okay, so this is okay, this product, and let it show the format also using the on. So its format name also, so block name on. Okay, then here we need one scope. Write scope, click on it. Now we need 3 input scope. Okay, so I will right click on scope. I will go for signal and ports. Number of input, I will make it to 3. Okay, so we need 3 input. What we are because we are using message signal also, carrier signal also, and then we are using the AM modulated signal also to look into scope. Okay, so this is my input part. This is my AM modulated part. It is already done. Now next block is saturation block. So I will saturation. Okay, saturation. So upper limit I will give 3, lower limit I will give 0. Okay, that is okay. 3 and 0 is okay. Okay, so you have to take the parameter screenshot also. Okay, like I have attached it here. Okay, see constant is 1. See, I have attached saturation. This upper limit you can see on right side. It is 3 and lower limit is 0. Okay, so everything I have attached. Like this only you have to attach. What is the next thing? Saturation done. Now we need analog filter. Analog filter you can see here. This is the analog filter. Okay, this is the analog filter design we need, in which we will select Butterworth, low pass, and filter order is 3 and pass band will be 100. Okay, so we need one analog filter here. I will search for analog filter design. There is one analog filter design. Okay, click on that. Okay, this came. I will go for double click. Filter order I will keep 3, no problem. Pass band I will keep 100, no issue. Okay, this is on Butterworth only. They see they are different filters. Okay, you will learn about all these filters. Filter type is low pass. We can go for high pass also, band pass also, band stop also. Okay, but right now we need only low pass. Okay, so this is done. Now next what we need, and next we need one DC shift. DC shift means constant only. So I will give constant and here. Okay, the constant is 1. I need to change this constant from 1 to it will go from 0 point minus 0.35 I will give, and this one is 0.001. So this is acting as a DC shift. So I am adding some minus part. So it will shift our output. Okay, by adding some minus part in that. And for addition, we need another sum. Sum is here. Okay, and this is okay. Now we need one gain. Gain. Okay, and gain should be 5. Okay, done. Now what we need? Need one scoop also for observing the output. So one scoop we need to observe the. I have to change the first. I have to open show the format name by right clicking on, again right click and change the number of input to 3. Okay, and yeah, change its name also to on. This is gain. This is sum. This is constant. Okay, this is a log filter design. This is saturation. This is scoop. Okay, so all this have, okay, I haven't shown this one. So all the block name is already done. Now what we have to do? We have to do the connections. Okay, like wires. So first of all, you don't have to select anything. Just drag using your left mouse key. Just drag and drop. Okay, this is connected. Okay, this is how you connection. Just drag and drop. If you have to do the connection here, drop it. Leave your left key. Okay, it will be connected. Okay, just drag and leave your left key. Using left click only, you have to drag. Okay, so using your left key, you have to drag. Okay, so next again drag and leave it. Now what we need one branch coming out from here, and it will go to the scoop. Okay, so that we can observe our messaging. So for that, for taking any branch from this connection, just press one, move your cursor here and press the right click, not the left click, and drag it till this connection. Okay, now it's done. That's how we do. And on second, we will observe this, right click again, and we will connect it to the second. Okay, and then third, we will use this one, and sorry, just delete this one, and connect it here. Third, we need, I will connect this one, and then again we connect it till here. Okay, so this is the in our input. What we need to mention the ports here, what are we are connecting. So I will go for this, right click here on scoop, go for signal and ports, and I will go for input port signal properties. So port 1 is connected to our message signal, so I will write its name, message signal. So it will display this name. Okay, so you can see this is the message signal, it came here. Now again I will go for signal and port, right click, input port signal, port 2. Port 2 is connected to carrier signal. Okay, so this is our port 2. Port 3 is connected to our AM signal. Okay, so this is our port 3. This is how we mention each and every name of ports in a scoop. So I will connect again this one, drag and drop. Again I will go for this one. This will also go for this one, and now for this one. Now this will go to this port, and I have to take branch from here. So I will do right click and take one branch, and I will connect to this. I have to take one branch from here, right click and connect to this. Now name the ports of each and every ports of scoop. So this is how right click signal and port, go to input port properties. Port 1 is coming from saturation. I will write saturation signal. Okay, now this second one also we need to mention it. Second one is the Butterworth LPF. I will write LPF for low pass filter. Okay, write it down. And this is the final one, which is our demodulated signal. Demodulated signal. Okay, this is our output. Okay, so you have seen this. Now save this one using this button. Save each and everything. Okay, save whatever name you give. See, I have already saved it in a different format. I will save it in the name of practice. Okay, save it in some folder. And for you people, upload this folder in your in some folder, and upload this folder in your Google Drive, so that you can use this in future. It will be safe for you people. So I have saved this. Now what I will do, I will run this program using clicking on this run button. Okay, here, see, it is running. On below you can see it is running. It will take some time for compiling. Okay, so it's compiled. Now what we need, just do this one. Just double click on this scoop. What happened? Yeah, this scoop is there. Okay, yeah, this is scoop output is there. Okay, it was not finished at that moment. Right now it's finished, so this is scoop part is there. So you can see here all the three ports output is shown here. Message signal, carrier signal. Okay, it is written as carrier signal. That was my mistake. So I will change it to carrier signal. Right click, signal port, input signal port 2, and I will change it to carrier signal. Okay, so again I will observe the output. For that I have to again run the program to see the changes. Okay, so it is run. Now I will observe the output. Now what you have to do, right click on here, go to configuration properties. Okay, your configuration property will be open, display is open, go to main. See, the number of input port is 3, so you are getting 3 waveforms here, but it is merged in one waveform. We want it separate, so go for layout here and go for 3 row. Okay, and click OK. Click OK. Okay, so this is separated here. This is separated here. You can see. So at above, you can see this is our message signal. This is our carrier signal. When I will zoom in this, then you will see the exact signal. Our frequency is quite high. That's why you are looking at a constant output, but it is okay. And this is our AM signal, modulated signal. You can, I will go for, just wait. I will go for zoom in. So you will see the, okay. So it will be very, it will go zoom, so you can't see after some point. But here you can see the overall output. So this is our AM signal. This is under modulated. You can change the amplitude of your signal generator and you will see the over modulated or critical one. Okay, so this is how you observe the output. You can open this or this or this. Just remove this one first. Just remove this one. Okay, so this is okay. Just remove, go to zoom out, restore view. Okay, yeah, no problem with that. Just save this image and include it in your lab report. So this is your AM modulated signal output one. And secondly, you go for this scoop also. Just double click on here. Now separate this one. Again, go to configuration property, go to main, go for layout. I will go for 3. Okay. Okay. So on above, you can see this saturation signal. I have given its limit. So limit is quite low, going from 0 to 1.5 till that. So it has some message signal inside this. It has some carrier signal and some message signal. Carrier signal frequency is quite high and this message signal frequency is quite low. But we need this message signal at our receiver end, okay, so that you can listen to the message. So we have connected one Butterworth LPF input, and in Butterworth LPF input, you can see the output of this LPF, low pass filter, Butterworth low pass filter. It is very low, okay, but we can able to extract the message signal. This is our advantage of this filter. Now what we have done, we have given it some gain, so we can amplify our message signal. So here you can see the amplification, okay, and we can amplify our message signal, and it is in this form. So this is our modulated signal, demodulated signal. This is same as the message signal we have sent it with our source. So this is how we do this simulation. Okay, so this is what simulation is. So that's all for today. This is the two experiments, one for coding and one for simulation. Save this output waveform and include it in your lab report. Prepare lab report properly. Okay, so that's all for today. Thank you.